Greetings, I am Shad and I have no idea why I am speaking like a robot. And this is the final video on the katana, or the samurai sword. Who would have thought that our great journey would have brought us here? Maybe all of you, because this is exactly where I said would end up. And where are we exactly? If you are new to this series, well, we are talking about the katana's design or dimensions. And in the previous videos, I talk about what the katana is made out of and how it is made. But in this video, to understand what we're going to talk about in this video, you actually don't necessarily need to have watched the previous ones. Of course, I encourage you to watch them. I feel you will find some very useful information in them. But in this video, in regards to how the katana is designed and what effects that causes in its use, how effective it is as a sword, very little is impacted on those things in regards to how it's made. Now, you need to understand what I mean when I say that, because of course how something is made is going to impact it. But once you get to a certain level of quality, which is basically getting the steel, the quality of the sword, or even how it's made, to a serviceable level, it doesn't really matter how you got to that level. As long as the manufacturing process produces a serviceable sword that will hold up well or endure well the uses that a sword is put to, there is not going to be any significant impact into how this sword performs when in use. So it's funny that there are many people in the world who believe the thing that makes a katana is specifically the way it's made, and it's not a true katana unless it's been differentially hardened and has the proper Hammond line and has been folded 1,000 times. Even though katanas aren't folded 1,000 times, they're folded between 7 and 12 times, and that results in can result in up to 1,000 layers. They're not folded that many times, but they say if that hasn't been done, it is not a true katana. Bull crap. The strengths that a katana has in general use, and the reasons why a katana performs like a katana when used, is because of its design, not the way it's made. So those people who say that a sword is only a true type of sword or certain type of sword and will not perform the same way this specific sword is supposed to perform like unless it's been made a certain way, I believe reveal a certain level of ignorance on the subject. Because like I said, all you need to do is get to that serviceable level, adequate, that it is strong or strong enough, durable enough, and that it will survive the uses that swords are put to. That is really all you need. Of course, having said that, there are strengths and weaknesses that will be inherent in the sword itself, depending on how it's made, and that's what we kind of talk about in the previous videos. For instance, spring steel is very durable and will spring back when under high stresses, and really hard steel will have success getting through hard materials like bone. But these differences really only matter in a big deal when the sword gets put under huge amounts of stress. And if you're using a sword in the proper way, you will generally be able to avoid that. But if there is at least a small effect that comes into the use of a sword that sits outside of its design, which is what I say is the main thing that determines how good a sword is, let's quickly touch on what that is and what it is in regards to the katana, because the katana has a very hard edge and a soft back. What that means is that because of the type of steel that is now in the sword, that it will be less prone to vibrate. And spring steels have the freedom to vibrate quite a lot because they have so much flex. And that is really it, especially in regards to a differentially hardened sword and a spring steel sword. It is vibration. One will be prone to vibrate more than the other. So even though this has a small effect into how a sword performs, what actually has the greater effect in regards to how much a sword will vibrate will be its design, its shape. Specifically, the sword's cross-sectional geometry. That very much so determines how much a sword will vibrate or not, because it provides the actual structure. We're talking about the outside structure now, because we talked about the crystal structure. Now we're talking about the actual form, the cross-sectional structure of the sword. That determines far more if a sword will be prone to vibration or not, and also how stiff and rigid it will be compared to the type of steel it has been made out of. Now, vibration, why is that important? Well, if a sword is prone to vibrating a lot, like really heavily, when it gets struck or when it impacts something, it means that it is harder for the blade to dig into the target. It actually makes it a bit more difficult to cut with the sword. And what I'm really talking about, and where this really comes into play in a big level, is in edge alignment. You see, if you have a sword that has a lot of flex, specifically a spring-steeled sword, but again, when I say spring-steeled, it's not the actual steel that determines vibration, because you can get a spring-steel sword that is very, very rigid, okay, and stiff, and that is more determined by, again, its cross-sectional geometry. So really, if the sword can vibrate more thanks to its actual design, what that means is if the edge alignment is off in a cut, it can bounce off the target completely. It'll shake, vibrate, and boing, and bounce off. Now, if you're wondering what edge alignment is, it's a very simple thing. It's that the edge or angle of the sword is on the exact same angle as the motion that it travels in, okay? And so if you have a sword, its blade, traveling in the motion that its cut is moving in, it will cut very cleanly. But if the sword's angle or blade is off, so it's a bit off, and then it's moving in an angle like that, when it hits something, it'll want to kick up. It actually won't want to dig in. And if a sword isn't rigid, that vibration from that kick will actually make the sword bounce off. But if the sword is rigid, okay, it will still bite in, even if the edge alignment is off, and then once it bites in, it'll actually correct the motion of the cut, and you will generally still be able to cut through the target, or at least cut into the target. And katanas are particularly rigid swords because they're mostly made out of soft steel with a hard edge, and that simply means that they don't have flex or give in them, and so they will be less prone to vibrate, and that's in contrast to spring steel where because of the flex they will be, vibrate a lot. But again, that's only a very small effect, okay? What really determines it is how it's made. So now let's look at how the katana is designed, okay, its shape, and why that specifically makes a more rigid structure, because these are the pros and cons. Now, I'll give a quick answer as to why the katana is more rigid than other swords, and that is simply because it is a single-edged sword. And this means if other single-edged swords share certain design features that the katana also has, they will also get the result of being more rigid because of their design. So why does being single-edged make it more rigid or capable of being more rigid than a double-edged sword? And the answer is simple. It doesn't have to have a back edge. Whatever edges are on a double-edged sword, you can essentially cut in half and make a single-edged sword out of it. And so when you do that, the mass that would have gone into making the second back edge can go into the single-edged sword, making it wider. And so the answer to how can a single-edged sword be more rigid than a double-edged sword is that they can get away with being wider generally than double-edged swords while not being heavier than them. And here we kind of just come to simple engineering principles. Width can make stronger structures. And indeed, when we come to the double-edged swords that want to be more effective in the thrust, you'll notice that they have a different cross-sectional geometry as opposed to earlier period swords, or simply swords that are double-edged swords that focus on being good at cuts, have a flat hexagonal cross-section. But with swords in the later periods that focus on thrusting a bit more, they can still cut effectively, but to be more efficient in the thrust, their cross-section changes to a diamond cross-section. And this central diamond, sometimes they even make the central ridge kind of jut out a bit further to make a really strong central ridge in the sword to make it stiffer. And this is simple principles of engineering. You see, so when a sword flexes or indeed bends, two things happen to the sword: compression and tension. Compression is on the side of the sword that's getting bent down and things get compressed in, and on the back edge of the curve that's being bent down, that comes under tension. Now what happens when you separate the compression point from the tension point from the central point, the further they are away, the more leverage the compression and tension points have in the bend, which means that they can resist the bend more. And so this is why the famous I-beams, if you have a look at a standard standard I-beam. When an I-beam is put under stress, it wants to bend. The bottom of it gets put under tension and the top of it gets put under compression. And because in an I-beam, the compression and tension points are pushed decently far away, they have far more leverage to resist, and that's why they are so strong in their cross-sectional geometry. Well, these same principles come into play with swords. If the sword is wider or thicker, these points of compression and tension, and that really just depends on which way the sword is getting bent, the further it is away from the central point gives it more leverage to resist, and that is what makes a katana more stiff or rigid than other swords. It's also what makes diamond cross-sectional swords stiffer than other swords, because they are able to push out that central spine, the center ridge, which again gives more leverage on the points of compression and tension. So even though double-edged swords can become more rigid with a different cross-sectional geometry, for instance the diamond cross-section, even though it can become more rigid, in my opinion, and I think the principles of engineering also back me up in regards to this, is that a katana, because it has more edge, wider away from the point of center, will always be a more rigid design than a diamond cross-section design. And so this will make the katana more rigid than other sword designs. And again, it can get away with this because it's a single-edged blade. If it was a double-edged blade, it would fall into very much the same kind of strengths and weaknesses that you would get out of, say, the diamond cross-section. Because with the back blade, it has to get in narrow. And when you make the sides more narrow to go into the edge, the point, you simply lose the distance that those compression and tension points need to have to make the structure rigid, or more rigid than other designs. And so this comes to a truth about the katana, and this explains one of the truths and also misconceptions, arguments about, the katana and stuff like that, and that is why it is easier to cut with. And it's funny, I've actually heard people say the katana isn't easy to cut with, you have to learn so much to be able to cut well with it. I believe they're saying that because with any sword you need to know enough technique. I mean, even with a katana, if you have horrible edge alignment, you'll still do a terrible cut. It's just that with a katana, according to just what we've talked about now, even though there's other things that will come into it, you can get away and still cut effectively with poor edge alignment, more so with a katana than you can with other types of swords because of how rigid it is. And so this does make the katana easier to cut with than other swords. And so the people that say that the katana is harder to cut with than European swords, I disagree. With European swords, particularly because of the way they're designed, they're generally much thinner than the katana. They will be prone to vibrate a lot more than the katana, which makes edge alignment particularly important. So does this make the katana better at cutting than other swords? No. Well, when I say that, the point that we've just talked about, okay, the rigidity of the katana structure, that doesn't make it better at cutting than other swords. It makes it easier to cut with than other swords, okay? People who don't know much about swords, they don't have any practice to get edge alignment right or anything like that, they will generally be able to pick up a katana and still chop a tatami mat in two. Because a katana, and this is a famous quote, is forgiving in the cut. And I kind of like that. It's a nice statement. It conveys, I think, the right imagery that you need to understand this thing. And it is true, the katana is more forgiving in the cut because it vibrates less, and that's because it's such a stiff sword in comparison to thinner swords, and most European swords are much thinner. One reason is because so many of them are double-edged. But remember, that doesn't make it more effective at cutting, okay? That just makes it easier to cut with. But the katana is famed for being particularly effective in the cut. Okay, so is there something in its design that makes it better at cutting than other swords, and even indeed chopping? And there is, but that's not its rigidity. The rigidity is just with ease. In terms of effectiveness, or the ability to do deeper and bigger cuts, comes from its weight distribution. So just grabbing my katana from the wall, let's just do a quick, test to figure out where the point of balance is. And it is about, trying to find it, right here. Okay. Now, this is the point of balance for the katana, and it is significantly much further down the blade than with other swords. You see, if you want a sword to be kind of nimble in the wrist, or indeed fast, so you can redirect its movements very quickly, you want the point of balance as close to the leverage point, which is, will generally be where your fist or hand is. You want it as close to the leverage point as possible. But that's only with speed, quickness of movement, and it becomes particularly important with swords that have a big emphasis or focus on thrust, so very pointy, narrow swords. Low point of balance is important. But when it comes to swords that chop and cut really effectively, well, a high point of balance is what you want, and that's what the katana has. Having a point of balance as high up as where the katana has it makes it a very top-heavy sword, and I mean, you will feel that if you get any accurately designed and proportioned katana and pick it up, you will feel that this is a top-heavy sword, and that means more weight and leverage can be put towards the part of the sword that will be impacting or cutting the target. More force and weight behind the part of the blade that strikes the target means simply a bigger cut. And this applies to chops and cuts, and when I'm saying cut, I mean draw cuts. That applies very much to both types. So having a top-heavy sword isn't necessarily a bad thing if you intend to do lots of cuts with it, but it also means that redirecting the motion of that blade will be more difficult because the point of balance isn't, as close as other swords in regards to the leverage point that you'll be maneuvering the sword with, which is what your hands, where you're holding the thing. And it also makes thrusting with the katana more difficult because it's more difficult to aim. You have to deal with more weight past the leverage, which is your hands, on a katana than another type of sword. But it does make it cut decently well. The other thing that also helps it cut well is the fact that there's no secondary bevel on the edge. And so from the part of this blade which changes its angle to go down towards the edge, there is no secondary bevel where it cuts into the edge, which makes it very smooth. When that edge starts to cut into, material flesh, it will push apart the flesh very evenly. And of course, the more narrow an edge, the sharper it can become. So why is the katana more top-heavy than other swords? Well, for one, it doesn't have as much of a distal taper than other types of swords. And so a taper is when two lines go, when they're traveling forward, angled towards each other. That's a taper. And so with swords, they will taper to a point. Now, a distal taper is when you turn that sword sideways. It's that it still tapers on the sides of the swords towards the point. That's a distal taper, and the katana doesn't have much of a distal taper, so that makes it more top-heavy. Now, I mentioned that the katana can be wider than other swords, while at the same time not being as heavy. Well, that depends on how thick you still make the sword. When I say thick, I'm talking about the flat edge, how wide it is, or thick along that angle. Because if you keep the thickness that the sword has while still extending the length of that edge, well, then it'll end up being heavier than other swords. And generally a katana is heavier than other swords. And it's generally heavier because it's wider and they don't make the sword as, thin along the edge length. And so that makes it a bit more top heavy as well. No distal taper, generally thicker, generally heavier than other swords, and also its tang, which is the part of the blade that travels into the handle, doesn't always go the full length of the blade. In some cases it can, but in other cases it will only go halfway, and indeed most of the cases that I see, I only see the tang going halfway into the handle. But there are cases, like I said, of going the full way. But the other point that makes it more top heavy on top of this is that it doesn't have a pummel. Now, a pummel can be a very significant counterbalance on a sword, which lowers that point of balance to help it be much more nimble in the hands. But there are other cases where pummels are completely hollow, and so they haven't been put on there for a primary effect as being a counterbalance. But in my opinion, one of the main reasons, you want a big pummel is again for a counterbalance. So it really depends on how you want the pummel to affect the balance of the sword. But a katana has no pummel at all. So again, top heavy. So this is why the katana is generally considered a good cutter, and it can be considered better at cutting than other swords, but not the best, because other swords that share these same design principles will be just as effective at cutting as the katana. It's because it has no secondary bevel on the edge, and because it's a particularly top-heavy blade. And the katana is also particularly easy to cut with because it's so rigid. These are the reasons why, okay? Now you will notice that I haven't mentioned a design feature on the katana at all yet, and I've been talking about cutting, and this is a design feature that people generally point towards and say this is why the katana is, or another reason, or another thing that helps the katana cut so effectively. And the reason why I haven't mentioned it is because this part is a misconception. People think that the curve in the katana, because the katana is a curved sword, they think that the curve assists it and makes it more effective in cutting. This is actually incorrect. Now, it's true that having a curve in a sword will actually make it cut more effectively, because the geometry is when a sword is curved and you cut something with it, more of the sword will actually pass through and slice and cut through the target material. So that is true, but you need the curve to be of a significant enough angle to get a true beneficial effect out of it. And the curve on a katana is pittance, all right? It barely has a curve. Indeed, this is funny, right? The katana only has the curve in it because of the differential hardening process. In the quenching process, because there is a thinner layer of clay along the edge and a thicker layer of clay on the back, it means the front part of the sword will cool down quicker than the back. There is also less steel on the front part of the sword because it's the edge, it's the most narrow, thinnest part of the sword, so there's very steel there compared to the back of the sword, which cools down slower. And so what this means is, now, first off, you need to remember when steel cools down, it contracts, because when it's hot, it's expanded, so cooling down contracts. And so if this hand is the edge, and this hand represents the back of the sword, okay, when the sword goes in, first off, the edge is going to cool down and contract, which will pull the sword a bit this way, but then there's more steel on the back that's cooling down slower, and so then all that back steel will pull the sword this way, and that creates the curve in the katana. The curve was actually never put in intentionally. When the swordsmith is beating the shape, he makes it straight, and then it gets the curve from the quenching process. Now, if they wanted the katana to cut more effectively due to curvature, they would have put a much bigger, more pronounced curve in the blade. But because the curve only comes from the differential hardening process, the quenching stage, the curve is very, very shallow. So gradual, in fact, that it actually makes no significant difference in its cuts. Now, people will say that it does, and this is promoted on full-fledged documentaries and everything, that the katana is curved to make it cut more effectively. Again, this is bullcrap, and I will prove it to you. Behold my 3D model, all right? And so this is a 3D model that I made of a standard katana in correct proportions and design. It has the correct cross-sectional geometry, it has the right standard length in blade and handle, and it has the same standard curve specifically. Now, what you will notice on this 3D model is a silhouette of another blade just underneath it, and indeed that silhouette shows a straight blade. So this would be the blade of a katana if it was straight. And we are going to compare the two. Now, I made this model to perfect dimensions. This is millimeter for millimeter, the right size. And because it is done to scale, we can get accurate measurements from it. So these other lines that you see on the model are the points of rotation. Now, I did it so I could show a chop and also a draw cut, but really the significant one we want to look at is the draw cut. And so that's the only one I need to show you, because I only need to do this once once to prove my point. Because even with other types of cuts, just showing how this works with one type of cut and the difference between the katana's standard curve and if it was straight bladed, that the difference that this cut will show will be indicative or similar to the differences in almost any other type of draw cut. And so what we do, we have a square block here, and this is a 5 centimeter by 5 centimeter cube, but it's also long because it's cutting through. And then we have the katana moving down in a draw cut. So in this case, it's a draw cut where the katana is not held out straight, and so it's not, straight like that, but you're holding it more horizontal in front of you and you're pulling it down and you're making a proper draw cut. And so with the motions that I can put this 3D model through, I can mark the exact point on the blade when it first strikes the target. And so this is the first part of the cut, and then mark the exact point on the blade when it leaves the target and mark that point, and then measure the length between the two to find out the exact length of the cut. And this will tell us how much of the blade passes through the object that is being cut into. And so if the curve in a katana truly does improve its cutting ability, the length of the cut, or the length of the blade that moves through the object, should be of a significant increase to the straight bladed sword. And so with this 3D model, I've marked the points where the straight bladed sword first moves into the object and then leaves the object, and you'll notice that they are moving down and away. And so when the first point of the blade hits the object, you'll notice that it is actually moving away and it is doing a proper slicing draw cut, okay? And so I've marked that on the straight one and I've marked that on the katana, and then I've measured the cutting ratio along the edges of these blades. On this model, the cutting ratio of the straight bladed silhouette model that you see there is 7.14 centimeters. Now the cutting ratio of the katana's blade, which is slightly more curved, is 7.45 centimeters. That is a difference of 3 millimeters. That's nothing! Okay? And this is what I was saying. 3 mil difference in the cutting ratio will add no significant effect in the depth or severity of the cut. It doesn't do a thing. And so you need to understand that the katana's curve is nowhere near great enough to actually provide a significant enough effect in the cut to be worthy of note, reference, or credit. It is not worth any credit at all. Indeed, you can say so easily that the curve on the katana cuts just the same as a straight bladed sword, and the truth is there's the slightest difference, but that difference would not make any significant change in the severity of the cut. It's 3 millimeters. The type of curve you would need in a sword to actually get a significant benefit in cutting, significant enough to actually make note of and to give credit to, is a curve that is significantly steep. Indeed, it's like this curve. So the new blade silhouette that you see on the model is very indicative of, say, a tulwar or saber or scimitar. There are many examples of swords that have such a significant curve in their blade. And this is just kind of like a standard curve in these types of swords. Now, it's on the exact same model and it's going through the exact same cut from the exact same point of rotation. And I've done the exact same test and marked which part of, the first point on the blade that enters the target and the very point on the blade where it leaves the target, and then measured the cutting ratio between those 2 points to find out what the cutting ratio is and how much of an effect this curve puts into a cut. And the cutting ratio is 9.83 centimeters. That is 2.38 centimeters more cutting ratio than the katana had with its own curve. So the difference between the straight bladed sword and the katana was only 3 millimeters. But the difference between the standard katana and the much more curved silhouette that I've put there is 24 millimeters. That increase is 8 times as much as the increase the standard katana had over the straight blade. And an additional 2.4 centimeters in a cut, I would say, is enough to actually have a significant effect in the severity of the cut. Seriously, grab a tomato and a knife, put the knife on top of the tomato, and pull that knife along it for just 2.5 centimeters and see how deep that cut goes in. And that is the additional severity we could expect in a sword that has a much more pronounced curve than the katana has. So the statements that say the katana's curve helps in its cutting is complete bullcrap. It's not true! The katana is effective at cutting because of its weight distribution and its single bevel. And if you wanted to throw in ease of cutting with cutting effectiveness, because, I can see that, if something is easy to cut with, you would think, oh, then it's better at cutting. Well, if you want to throw that into it as well, it's because the katana has a much stiffer blade than many other swords. That is why the katana is good at cutting, not because of its curve. Its curve is nothing. And while I am stomping on the curve, I will go further and say the curve actually is a detrimental feature on the katana's design. Because one, the effect it puts into cuttings is so little that you shouldn't even mark it as a feature. Yet because it is curved, it changes the mechanics of the way it thrusts in a very, very big way. And this isn't a good big way, it's a detrimental big way. So the benefit is so little that it shouldn't even be regarded, yet its detriment is so great that, in my opinion, the curve shouldn't even be there. But remember, if a katana is to be made in the proper way a katana is to be made, you can't get rid of the curve, because the curve is an inescapable effect of the quenching process. So let me explain why the curve is detrimental to the overall design of a katana, and that is specifically in thrusts. Now, thrusting is an interesting topic in regards to a katana because it is good, yet it is not good for, two reasons. The first reason of why it is good is because it's stiff, it is very rigid, and any stiff, rigid sword will be good at thrusting. The bad thing at why the katana isn't good at thrusting is because it has so little taper on the edge. It does not have a thin, acute point, and so that makes it very difficult to thrust with, and so it's a pity because you've got the makings of a sword that could be very good at thrusting, yet it's ruined because it has no significant taper. But again, if you were to put that taper in, you would reduce its effectiveness in cutting. But that's the pro and con, okay? And so I've heard some people say the katana is great at thrusting simply because it's so rigid, but they don't actually say it's because it's rigid. They don't know what they're talking about. They just thrust and say, look how good this thrust was. But in regards to trying to get through mail or thick material and stuff like that, you need a much more acute point than what the katana has. But these two things do not even remotely touch on the main thing that comes into play when you thrust with a katana, and that's the curve. You see, the curve in a katana offsets the tip from the point of thrust. And this is very important because if you are thrusting with a sword, if you have the tip directly centered and in front of the point of thrust, all that force is going to be evenly transferred through the body of the blade to the tip and then hopefully into the target. If the tip is off-centered from the point of thrust, there is no even transferal of force along the whole blade. Indeed, parts of the blade will be under a lot more stress than other parts. And that's not good, okay? That actually means there are much higher chances of the blade failing because of this. You will see a lot of the force when you put into thrust gets transferred through the steepest part of the curve in the structure. And so one, that means there's higher chances of the blade bending out when you thrust with it, but you also lose some of the force you're putting into the thrust into the stress that's being put on the blade. And so any type of force that is actually trying to push this sword to bend, which inherently happens because the sword has a curve in it, is lost force from the thrust. That is force that is getting wasted and lost in the stress of the sword that could have been put into the thrust itself. So a straight blade transfers most of the force in the thrust, but a curved blade takes some of that force in its own stress as it strains against this new compression and tension that's being put into the curve. This is the detrimental effect you get out of having a curve in the katana, and it doesn't need to be a big curve for this to create create a significant problem. Indeed, the tip only has to be off-centered from the point of thrust by a little bit, and all these problems I've talked about will come into play. Of course, they are emphasized more on a blade with a much wider curve on them, but with swords like tulwars and sabers and scimitars, there's no emphasis or there's no argument to say that they are good at thrusting at all. But for people who love the katana, they do try and push and say, no, it's still really good at thrusting. Well, there are problems that come into play when you try and thrust with a katana. You would get rid of these problems by simply making the blade straight, and you wouldn't lose anything in regards to its cutting effectiveness either. Because again, if you really want to get a significant benefit out of a curved sword, you need that curve to be far more pronounced than what the katana has, and so they would have had to have put a curve in it when they're actually making it and not get the curve out of the quenching process or the quenching stage. Now, the katana is a two-handed sword, and that is a necessary design feature, I feel, because of how top-heavy it is. This sword, it would be far too cumbersome to try and wield around in one hand, and go and pick up a katana and try and use it in one hand. It's like trying to throw around a club. No, it isn't a one-handed weapon at all. The blade is long enough, or should I say short enough to be one-handed, but it's nowhere near light enough. It could be light enough, but not the point of balance. See, the point of balance is what really makes a sword more effective in one hand or not. The next design feature to look at would be the handguard, the tsuba. Tsuba. That is the disc guard on the katana. Now, I mean, the tsuba, it's sufficient to stop the hand from sliding down onto the blade. It's for the area that it does protect. It doesn't protect much because it's small, but for the area that it does actually protect, which is really only the forward top fist, it protects the whole fist because it's a round guard, but I feel it does have issues or limitations because of how small it is. Now, you wouldn't want a wide guard like this around like that would be ridiculous, but in my opinion, there are much better guards that have been put on swords throughout history, and I feel a cross guard is a more efficient and effective guard than a disc guard is. And it's true, the cross guard has a weakness on, the sides that it doesn't protect because it's only got, the forward and back guard on it. But again, then there was evolutions in the crossguard to put side rings on it, or those, the little nail that sticks out to protect the side as well, which offers, in my opinion, as much protection as the tsuba, and then more so, because a crossguard is a multi-purpose tool. It gives, these really useful points of leverage on the sword to try and lock, your opponent's sword and pull them out of the way. Very significant stuff, and I feel the katana misses out quite a lot because of, how little the guard is. Now, I've heard people say that, no, the tsuba is better because it doesn't get in the way, of the wrist, so you can kind of move it back without any, quillin poking you in the wrist, and you can get far more articulation and movement in it. Anyone who says that is very ignorant of the ways European swords can be used. Because they say that the quillin here will, hit the wrist when moving back. And the way to fix that? This. It's not that difficult. Now, having said all this, I remember when I first picked up a sword with a crossguard and I started using it. And I do remember the crossguard hitting my wrist when I was moving around, but it took about 10 minutes for me to correct and learn the ways of using and maneuvering this sword for that to not be an issue at all. And ever since then, it has never been an issue. I've never had the crossguard hit my wrist when moving it around because it's so easy to just learn and correct, your way of holding the sword to fix it. And these are the main design features of the katana. So we've gone through the dimensions of the blade, its cross-sectional geometry, its taper, how stiff and rigid it is, the effects of the curve, its weight distribution, its handle, it being a two-handed sword, and its guard. And so those kind of are all the design features that we can look at. And we have found strengths and weaknesses in looking at the design or the way that the katana is put together, its shape. And so yes, there are design flaws in the katana's shape. Now, there are flaws in many other types of swords as well, but what you will find in other parts of the world is that swords evolved quite a lot. There was all these innovations and changes and improvements. You won't really find that with the katana. Now, I'm more than aware that in Japan they have other types of swords other than the katana itself. But in terms of the katana itself, and so this is the two-handed Japanese sword, it did not change much at all throughout history, even up to now, the modern day. Sizes have varied, length of tangs in the handles have varied, the ratio of curve does vary, and so perhaps the katanas that have a really extensive curve could get an effect from it, or a beneficial effect from it, but you only get a true beneficial effect, like something that is so beneficial it's even worth mentioning, is when that curve is very, very steep. But you will find that the katana has not evolved much at all in its design, because there are ways you could fix these design flaws, and perhaps they would have been if, more evolution was allowed in katana's design and manufacturing. And so the first thing that I would do to improve these design flaws is, one, make the blade straight. It's getting nothing out of the curve it has in it. And I hope I've proven that in the 3D model I've shown you. And so yes, 3mm difference in the cutting ratio, but that is nothing that will give a significant effect. And then you get the detrimental effects in thrusting because of the curve, so I say get rid of the curve completely. Still keep it single-edged, alright? Because by having it being a single-edged sword, you can add more stiffness and rigidity in the structure, which will actually help it out in thrusting as well. And remember, it becomes so stiff and rigid because the points of compression and tension are further away from center. And so it can afford to be wider because it's single-edged. So I say, yeah, keep it single-edged, absolutely. You get some good benefits out of that. Now we come to the choice, because even if we straighten the blade and keep it single edge and keep it wide so it's stiff and everything like that, we will then choose weight distribution, because there are things we can add to the design which will affect it. For instance, a pummel. A pummel will bring the point of balance down the blade. If the crossguard is a little bit bigger, especially bigger than the tsuba, that will also bring point of balance lower. Now for myself, I prefer having point of balance lower than higher. I like, the sword being quicker in my hands, and because it's quicker, because I can redirect the momentum much easier, because the point of balance is closer to the points of leverage. And so I would make the tang go the full length of the handle, put a pummel on it, and I would give it a better guard, specifically a cross guard with maybe side rings or a nail on it. Now what is very interesting about these changes that I've just put on the katana to address these design flaws that I feel it has in it, these changes in design that I've put in the sword actually creates a new type of sword that technically already exists. It exists in some of its iterations, not in all of them, but the sword I'm talking about is the Kriegsmesser, which is a two-handed version of just the regular messer. The only difference in this new sword I'm proposing by trying to fix the design flaws in the katana, the only difference between a Kriegsmesser and this proposed, new katana I'm talking about is in curve, because a Kriegsmesser, it almost seems to be 50-50. You'll find a 50-50 chance of the messer having a slight curve in him, which in my opinion is pointless for the exact same reasons why the curve in a katana is pointless. It's nowhere near great enough to get a significant benefit from. But the other half of messers actually have no curve, and what's interesting about them, at their tip, they have kind of a kink at the tip that brings the tip closer in front of the point of thrust. And so to me, those type of messers are actually superior in design than the ones that have the gradual curve in them. Because these straight-bladed Kriegs messers are basically the exact type of sword I propose if you were to fix the design flaws in the katana. Now the Kriegsmesser did not come from an evolution of the katana, it was developed completely independently in Germany. And that serves to prove that logic can strike any person regardless of race or culture if they realize that, oh, look at these design features, that will make a stiffer blade. Well, guess what? I'll make it single-edged and thicker, stiffer blade. Because that's very much what many Kriegsmessers have. They have very similar cross-sectional geometry to a katana, and they get similar benefits, or the same benefits, from these design principles. And the Kriegsmesser is a phenomenal blade. I mean, look at how effective this thing can cut. And this is a Kriegsmesser that does have a slight curve in it, but it's cutting so effectively, not from the curve, because as we've been able to find out and discover and prove that such a very shallow, minute curve doesn't affect cutting at all. What is making this thing cut so effectively is, well, and easily, one, how stiff the blade is, and you'll recognize good old Skallagrim in the video, and in this video he even points out that the blade is particularly stiff. It's made out of spring steel, and so when they're under a huge amount of stress, when he strikes, you know, a piece of wood with poor edge alignment and flexes a lot, like, it can survive it because it's made out of spring steel. But even with it being out of spring steel, he says it's very rigid.
As far as the flexibility is concerned, it's stiff enough that I can't flex it very far by hand, but it's flexible enough to absorb a lot of shock.
And it gets its rigidity from how thick it is, and also its cross-sectional geometry, because the points of compression and tension are further away from center.
As far as the cutting performance is concerned, well, the consensus at the local historical martial arts club where I practice is that this is basically like a cheat code for cutting. It's like the Konami code of swords. It makes it very easy. Our instructor Eric was very impressed by how effortless it makes the cutting.
I didn't even feel it.
And a friend of mine who is not trained in swordsmanship and tried cutting for the first time did just fine with it. The blade really does a lot of the work for you.
And so it's cutting really effectively because, yes, it's easy to cut with because it's vibrating less because it's so stiff and rigid. It also has significant weight in the blade, which makes the cuts go deeper, and it also has a single bevel on it on top of that. And then combined with the fact that it is less prone to, you know, vibration because it's stiffer thanks to its cross-sectional geometry, it makes for a sword that is very effective at cutting. And just look at this thing, it's going through trees! And so yes, a Kriegsmesser is a phenomenal sword, and in my opinion, it is a great example of a sword that is very like the katana, but without the design flaws that a katana has in it. But of course, the design flaws kind of make a katana what it is. I mean, you know, could anyone rightly call a katana with a straight blade truly a katana? I could, you know. But see, traditionalists will say, no, it's only a katana if it's been differentially forged, if it has a hammered line, if it's got the right curve in it, if it's truly a katana. Well, if that is the case, if there is no room for evolution in what a katana truly is, then a katana is a flawed sword. That's not to say it doesn't have its strengths, okay? And I've mentioned what those strengths are, so I feel I've been very fair in my analysis here. But the fact is, it also has flaws that could be corrected. And so, if you're going to keep those flaws in and not correct it, that simply makes, like I said, a flawed design, a flawed sword, or a sword that is actually very far from perfect, and that is contrary to what so many people say in the world about the katana. Now, I have been looking at the katana's design in a very analytical and practical way, and really that's the thing. I've only been looking at how the katana's design affects its practical use. And to me, the practical use of a sword determines its quality far more so than anything else. But if I was to put aside my practical analysis of the katana's design, I can say very honestly that how the katana is looks beautiful. The katana is a sexy sword. And the slight shallow curve in it looks very elegant, all right? And so just from an aesthetic point of view, there's part of me that is reluctant to get rid of the curve because it just looks so nice. And so yes, the katana is beautiful. I do love the katana, but if you want to look at things objectively and fairly, you need to be willing to acknowledge the flaws in something, but maybe it's the flaws, the imperfections that make something beautiful, kind of like the human race. Oh wow, I'm getting really deep and philosophical. But that's just a bit of philosophical mumbo jumbo, and it doesn't even really apply to me. It might apply to other people that they like something because of its flaws. No, the things that make me like the katana is when I look at it as a whole, it looks beautiful. It is just, you know, a beautiful looking sword. And I can see its strengths in it as well. So there you go, that is the katana's design, why it is designed the way it is, and the strengths and weaknesses it receives as a result of that. It has been such a pleasure making this series. I do hope you've enjoyed. Thank you for watching them all, if you have watched them all. And I hope you have learnt something, and if not learnt something, I hope you have enjoyed yourself, that you found them at least entertaining. Now, I don't generally do this with my videos, but because this topic that we've been talking about, the katana, has so many misconceptions and is also a very popular one. People love the katana. And so because of that, I encourage you to share these videos if you feel prompted to do so, or if you find an opportunity to. If you're talking to people about the katana, if you're on a forum post or anything like that, I do encourage you to share these videos, because I feel that we have been able to talk about certain things that I have not found other videos talk about. It's one of the very reasons why I felt the need to make this series. To clear up misconceptions, to discover truth! So please do share if you can, simply to educate those people who are spreading misinformation. But even if you don't, I am incredibly grateful for the fact that you've even watched them. So thank you for joining with me. And that's it! We're done! We've come to the end! Cut, print, edit! That's all, folks! See you later! Thanks for watching! I'm going on holiday! Now I have no idea what to do with my life.